Hello and welcome. I'm Daniel. I'm the author of the LangChain for JavaScript Developers book. Today I'm excited to share with you my interview with Ishan Anand. I've discovered Ishan while watching this year recordings of the AI Engineering World's Fair. Ishan talked about how he was able to implement GPT-2 into Excel. Yeah, you heard that right, directly into pure Excel. Okay, a very big Excel file, but still just a pure spreadsheet. And I was fascinated by this because I think that once you are able to implement a model like so, you have to really understand how it works until the smallest details, not just to have a brief overview of the LLM. I think that once you are able to do this, you become a better engineer because you can understand how an LLM works. On the other side, you can read and understand the research papers. And maybe the most important, you can be the rational voice when other people are assigning these magical powers to AI. So enjoy this interview with Ishan. He's a fantastic teacher and has a lot of very valuable informations to share. Let's dive in.
Let's
Hi,
go.
Ishan, and welcome. Nice to have you here. Thanks a lot for
Thank you.
taking the time for joining the podcast. Maybe we can start with you telling us a bit about your background, whatever you consider relevant.
Sure. Well, first off, thank you for having me. I'm Ishan. I'm the creator of Spreadsheets Are All You Need. That's a spreadsheet that makes AI easier to learn by implementing a real large language model. So real, in fact, it was actually considered too dangerous to release when OpenAI first created it, entirely inside a spreadsheet. So no programming required, no Python, no macros, just pure Excel functions. And it's also the foundation for a course that I teach to professionals to help them grow their careers by quickly giving them that AI degree they're missing. So they can go beyond just prompting these models to understanding precisely how they work on the inside so they can be the experts in the room on the AI projects at their companies. The key thing about my background for my audience is that for a lot of them, I have been where they are now. I have been a software engineer up and down the stack. So device drivers for the computer music industry. If you know this company, Pro Tools, I worked on that. I've done native mobile applications. I've done cloud. I've done web development. I've been a tech executive. So I was CTO at a company called Layer Zero. We were an enterprise-focused Jamstack platform. I have been a technical B2B enterprise product manager. I was vice president of product at one of the largest CDNs. We combined serverless, AI, edge computing into a platform for web security, web acceleration, and hosting. So I bring a lot of that background to making AI as easy to understand as possible, but still understand precisely how it works. I like to say, if you can read a spreadsheet, then you can understand AI. And so I'm trying to basically raise our general public AI IQ, so to speak.
Fantastic, super cool. As a competition to what you said, I think the model that you are referring to, the model that you are creating in the Excel, it's actually GPT-2, no? Or a
Yeah,
very slim version
no,
of
no,
it.
it is GPT-2. It's a version of GPT-2 called GPT-2 Small. And for those who don't know in the audience, GPT-2 was an early precursor to the more famous ChatGPT. So GPT-2 came out in 2019. There was a GPT-1, then there was a GPT-2, which is what's implemented in the sheet. Then GPT-3 was never released in open source. And then we got GPT 3.5 or ChatGPT. That's where the GPT comes from. It is weight for weight compatible. It runs the exact same weights as the 124 million parameter
Well,
model that OpenAI released. All of those 124 million parameters are sitting there inside the spreadsheet. You know, we talk often about like parameters, and you know, one of the things I do in my class, I'm like, do you want to see what 124 million parameters looks like? And it's just a wall of numbers, like sitting in a
yeah.
spreadsheet. Yeah. That's all it really is. So yes, it's that model, but the full OpenAI weights.
Okay, super cool. Um, I'm interested a bit about on your origin story when it comes to AI. Did you, I know you mentioned in another podcast you did some courses in college
Yeah.
regarding AI, but from the moment you finish college till now, did you did something else regarding to AI? How was your relationship with AI evolved in during this time?
Yeah, it's a great question. Actually, the key thing to know about, when I was in college is the AI class I took, the one thing they left out was neural networks. That was the thing, like, everyone knew wasn't going to work. That's how long ago it was. And then basically starting in the 2010s, when deep learning started making progress, I was like, oh, I need to pay attention to this. So, I did Andrew Ng's, famous class, and I looked into like TensorFlow.js because web development background. To date myself, back then, uh, Endering's course was using Octave. Like, this was before PyTorch and
Okay.
TensorFlow. So it was the really early version of it. So there was no actual exposure to large language models. It was just more broad AI background. And I hadn't really touched large language models until, like most folks, the Chat GPT moment. And like many folks, I was both inspired and fascinated that I had to completely dig in and immerse myself as much as I could when I really had a free moment into understanding how these things work. And then at that point, I was like, I was watching actually Jeremy Howard. He does a lot of stuff in his
Hmm.
class where he uses in Fast AI where they use spreadsheets to teach things. And I suddenly realized, well, the whole thing really is a large computational graph. Maybe I can get a whole model to work. That might be a really interesting and accessible demo that shows this is really a giant calculator. And that's how I got started on it. And it took about 2 months of kind of nights and weekends
Yeah.
to get working. But I don't want to say that to scare people. It's actually, a lot simpler than most people realize. I have a video I put out last week where I point out like the original GPT-2 implementation is only 500 lines of code.
Hmm. Hmm.
And my class is only about like 5 hours. So it's an amazingly fascinating program, but I think it's something that's actually easier to learn. LLMs specifically, not broad AI. There's a lot of
Yeah.
things in it, but just understanding how these LLMs work is something that I think a lot more people can do and don't realize how approachable it is.
Okay, okay. Wow, super interesting. By the way, I'm curious because you mentioned TensorFlow, especially TensorFlow.js.
Yeah.
Have you done stuff with it? That was my first, I don't know, my first link between JavaScript and AI, and I use it a bit, but just to train some very simple. Was that famous playground, the TensorFlow
Yeah.
playground? Where you could design your network and so on. Have you tried to do all of that and to train networks from scratch?
I've probably done as much as you described. Like I used the
Mhm.
playground, I learned it, I had the concepts. By that point, I was more like a manager than an actual
Mhm.
day-to-day implementer. So I haven't made any projects of note out of TensorFlow.js. I am actually looking at browser implementation though. One of the things that I get a lot of people contacting me about is, spreadsheets are all you need only runs in Excel right now. It's too big to run inside Google
Yeah.
Sheets, although I'm working on trying to resolve that to a certain extent. And if you go into GitHub where the sheet is posted, one of the open issues, one of the most active ones is, can we port this whole thing to the web browser? And you can certainly run GPT-2 inside a browser, but the key thing is first run a spreadsheet such that we can show the model as a spreadsheet. So we first have to build the spreadsheet interface and then build the GPT-2 on top of it. And that's something that I've started looking into as well, is how we can bring this to more people so they don't need to necessarily have Excel and they can just simply run it inside a browser, but still keep it as accessible as possible in a way like a JavaScript implementation or, Transformers.js is great for production use cases, but this is really about making it more accessible. The analogy I like to give is we often talk about the importance of open source in AI. There's another more powerful force I feel, and that's view source, right? The
Mhm.
web browser, when it first came out, had this great button.
Yeah,
It's
yeah,
still, we can go and view source. And
exactly.
plenty of people like opened that thing up and realized, hey, I can do this. And the spreadsheet form of a large language model hopefully will do the same for you. They look at it and they're like, oh, it's only X number of lines of formulas. I
Yeah.
can do this. I can at least understand how it's working. Maybe I can't train the model. And that's really my goal, is to kind of bring that view source to AI.
Wow, fantastic. Super nice. By the way, we will link in the description and in this page for this podcast all the talks or the links that we are mentioning here. But I really liked your talk at the AI Engineer World Fair this year.
Thank
Maybe
you.
you can, that link for sure will be there, but maybe you can talk us a bit through a brief overview of that talk. How was it? What you're doing in that talk? Just a brief introduction in it.
Yeah, sure. So first of all, thanks to the AI Engineer World's Fair in San Francisco for having me. I had a lot of fun presenting it. The talk is a very short 20-minute introduction to how large language models actually work using spreadsheets are all you need. But to make it engaging and entertaining, I use this brain surgery metaphor. So I dressed up in scrubs on stage, as you'll see. And the setup is that me and the audience are going to go through this AI brain surgery med school. So the first thing we do is anatomy. So we understand what all the parts of our patient is GPT-2 that we're
Mhm.
going to be operating on. And our operating table is a table. It's a table of numbers. It's the spreadsheet. And so we first understand its anatomy. Then the second thing we do is we take GPT-2 and we put it through a virtual MRI. It's a technique called logit lens that's been around for I think about 5 years now in the LLM community. And we try to understand how it's thinking. So we put it through a few tasks, and then we look at how it behaves under this virtual MRI. And the last thing we do is AI brain surgery now that we've graduated. And we change its thinking without prompting. We use the same technique, or our cousin technique, to what they use for Golden Gate Claude, where they kind of made it talk only about the Golden Gate Bridge. We do that inside the spreadsheet. And it turns out, there's a lot of research that went behind it, but we can illustrate it very simply inside that session. And we do all that in about 20 minutes.
Fantastic.
That's the talk. Yeah.
Fantastic, fantastic. Yeah. By the way, during the talk, two topics popped into my mind, and of course, each viewer will have a different experience. But for me, was one of them was the attention mechanism of LLMs. How would you explain this attention mechanism to someone who just starts in this field, in the LLM field? What is attention, and what are the advantages of implementing this mechanism?
Yeah, great question. Before I tackle that question, I first like to take a step back and describe the transformer as a whole. The attention is what
Yep,
makes a transformer a transformer. But the starting point here is to just say, these programs, as most people have heard, have been taught to fill in the blank, right? So the example I use in my talk is Mike is quick, he moves blank. And that blank can be filled in with the word he moves fast or he moves quickly. And the question is, how do you get a computer to do that? And the simple analogy is, well, a fill in the blank a computer can do really well is 1 plus 1, right? 1 plus 1 equals
sure.
2. They're good at doing math. So what the transformer really tries to do, and all large language models, is they take a word problem, Mike is fast, he moves, Mike is quick, he moves blank, and turn it into a number problem where it's just mapping each of the words into what we call tokens. Well, they're broken apart into subword units. We can ignore that. But each of the words are mapped to numbers, a string of numbers. And then we basically have a mathematical calculation we do on them instead of doing text. And then we take that result of that calculation and we turn that into a probability distribution around a set of possible completions for the blank. So it could be fast, around, quickly, inside the example I used, Mike is quick. Inside that number crunching, there are two key mechanisms. One is the neural network, or the multi-layer perceptron. The other one is the one you brought up, which is attention. Attention is really this idea that inside, the large language model, each token can look around at the tokens around it. Well, inside GPT, it only looks, it can't look forward, it can only look backwards, but it looks backwards at the other tokens to understand the context of the passage it's working on. So the example I use, which we had Mike is quick, he moves. So he could look at Mike, which is the antecedent to the pronoun he. Another thing it could do is moves could look at the word quick. And the word quick in English has multiple meanings. So it can mean moving fast, but it can also mean bright, as in quick of wit. It can mean alive or dead, as in the phrase the quick and the dead in Shakespearean English. It can also be a body part. It can be the quick of your fingernail. And so it will use the attention mechanism to disambiguate, oh, the word moves is here. So it's the physical movement version of quick. It's not something about your finger. And another way to think about attention is it's playing a guessing game, right? If you're trying to complete a sentence, the best thing you could possibly do is look at every single possible word that came before it. That's the most information you would have. Previous attempts at large language models were these RNNs, recurrent neural networks. And instead of looking at all the previous words, what they did is they basically created a mathematical summation or accumulation of those words and used that to reason about what the next word was going to be, which is somehow inherently less information. It's more efficient, though, to compute. However, it turns out the way the transformer works, you can parallelize that compute really well, such that you can get a lot of data at scale being learned. So that's the key unlock of the transformer mechanism, is it gave it a lot of information and it gave us the ability to train it on a lot of information in a very parallelizable way. So that's the attention mechanism. Sorry, what was the second part of it you wanted me to go into?
Uh,
Yeah.
the second part, I didn't mention it yet.
Oh,
By the way, I think the attention mechanism was first introduced in the Attention is All You Need, the paper, the research paper, if someone is interested. The
yeah.
second part, actually, you mentioned it a bit earlier, is the Golden Gate Claude
Yeah.
experiment. That one for me was fantastic. I mean, was wow, mind blowing.
Yeah.
Can you tell us a bit what does it mean, and also what are the practical implications of this discovery, let's say?
Yeah, that's a great question. One thing, attention actually existed prior to attention is all you
Mhm.
need. The innovation, to be precise, on attention is all you need was that they got rid of everything else and they just said you only needed attention. There were a bunch of
Ah,
other
okay.
mechanisms inside RNNs to have this kind of attention mechanism. But the real innovation in that paper was to say, you know what, let's get rid of all those other things and just keep two things: the multi-layer perceptron, the neural network, and attention. And those two things are all you need. I mean, technically, you also need a ton of money for GPUs and a ton of
Correct,
data,
correct,
but we can forget about that. From a research perspective, that's all you need, at least.
correct.
So for Golden Gate Claude, so first we should tell people what we're talking about.
Exactly.
So Golden Gate Claude was something that was rolled out earlier this summer by Anthropic, where it was a version of the Claude, large language model that had been forced through a technique to only talk about the Golden Gate Bridge. And the basis for this research goes back to last year, where the same team basically discovered something called sparse autoencoders, which are a technique to look inside the brain of the large language model and the numbers that go through and turn those into interpretable features. What's really interesting is there's this technique that's been around for a while called an autoencoder. We don't have to go into the detail for it,
Mhm.
but the job of the autoencoder was to kind of compress the amount of space, compress and represent whatever piece of information in a more manipulatable way, but often in what they call a bottleneck. And what they did with the sparse autoencoders, they said, well, let's expand it out to many different things and then figure out what features are being activated. So they made it what they call sparse, so that only a few of these features get activated. And they were able to say, find an activation that only happened if, the Golden Gate Bridge was being talked about, or cities were only being talked about. There was one famous example where there was an activation that only triggered when there was a bug inside code. And what they then did to prove that this was actually, causal within the model is they took those activations and they injected those back into the model. And it turned out it would shape its thinking. So in the case of Golden Gate Claude, it would take the Golden Gate Bridge and it would only talk about the bridge. In the case of that thing that was for bugs in code, it would be shown buggy code and it couldn't tell that the code was there. It would answer the problem as if the code was correct. And so that's kind of a high-level summary of the way the sparse encoder works. We're basically taking another AI technique to look inside our large language model and turn it into interpretable features. It turns out to be a really flexible and powerful technique. The practical implications, I think that's a little bit TBD. There's definitely the ability to steer the model, but you can also steer a model with prompting, and it may turn out to be more efficient computationally. It might be useful as a form of guardrails. So you might be able to detect when the model is misbehaving or operating in some unaligned way. It might be useful for synthetic data generation. So for example, when you're using a large language model distillation, you could use it to make sure that none of the examples meet some type of criteria you're able to control through steering. Those are some possible applications. The Golden Gate Cloud was turned into an API that I believe is still in beta. And so it remains to be seen. It's definitely a very powerful technique. It's been replicated for many different models. There's a team behind a website called Neuronpedia from Neil Nanda, Joseph Bloom, Johnny Lin, and they're posting these sparse autoencoders for a lot of open source models. So GPT-2 is one of them, which is how I was able to do this for the talk. But there's a few others that you can go and see what those autoencoders are and be able to leverage them. But in data application, like you might be able to achieve similar results through proper prompting. There's a really good post from Neil Nanda, actually, where he talks about a lot of people thought this meant this was a better way to control the model and steer it than prompting. And he's like, not so fast. We don't know that. Okay. But it's certainly, I think, one of the hottest and most interesting areas of what we call this research area called mechanistic interpretability, which tries to understand how a model works. So definitely really fascinating. And I was so excited. I was able to take something that was so cutting edge research and put it inside a talk and make it as accessible as we were able to do in that short 20-minute talk. Thanks to the work of all those other people I mentioned.
Okay, fantastic. I think what you done was something related to the Star Wars universe. So
in my talk, I take the Jedi activations. They found a feature that activates for Jedi. Turns out there's a bunch of them, and I inject that into the model, and then I change its output. So instead of like pulling out his phone, he pulls out his lightsaber.
Yeah.
So it's a very fun example.
Yeah. Nice.
And so I have a lightsaber on stage as well, just it was a lot of fun. Yeah.
Correct. Let's talk a bit about education. And one of the first questions I would want to ask you is how one can balance learning about AI while having a day-to-day job that is not directly related to AI. Let's say I am a like traditional software engineer who does web development. What would be a good bet in your opinion to educate myself so that I can become valuable in this AI field? Because I'm more and more sure that it will change the world as much as the internet, or at least as much as the internet done. So how would you make like a learning routine?
Yeah, it's a great question. And I'll underscore that one of my friends, he has a great line he keeps repeating to me. I forgot who said it, which is like, in the future, all jobs will be AI jobs. So the question is really relevant. One of the things I do is my class, which tries to do in 5 hours, help people understand how AI works under the hood. But there's a lot out there, and like that's just the internals. There's agents. There's a whole slew of AI stuff out there. So first of all, it might help to understand what AI you're talking about and which one matters. In your job, maybe it's traditional AI or classical AI rather than the large language model. But let's talk about large language models because that's what
exactly. Correct.
So for that, I recommend a few things. First is I have a few recommended sources that I use to stay on top of the latest information. So do it by proxy, right? And four that I'll recommend. So Latent Space from Swix, Sean Wang. He has a newsletter called Small AI that is fantastic. Don't feel like you have to read all of it. In fact, maybe I should step back. The thing you should figure out is what part of AI you want to focus on. Which part, even within large language models, whether it's using them and prompting them or engineering on them, or whether it's their internals. But small AI is great. It has a great list, and that's SMOL dash AI,
Or
not SMALL. The
we'll
other
link it.
one,
We'll make
yeah,
sure that
yeah.
is linked.
Let's link to it. So another one is Thursday AI, which is Alex Volkov's weekly podcast, where it's actually a Twitter, or formerly Twitter, now X space, where he has a lot of great guests. It's a great way to understand what's happening from the engineering perspective with AI. Another one is Cognitive Revolution, which tends to be more about the research areas in AI. And then I have a product management background, so I find NLW's AI Daily Brief a really great way to stay up to date on the latest kind of from product and business side news of how AI is being viewed. Even if you kind of know the technical stuff, and even if you feel like you're ahead of the curve, you really need to understand where the rest of the market is and what's of most importance there. And I find he does a really great job in both his summaries and his deep dives. So those are kind of the four I recommend. The others recommendations I have is have a project. Having a
Exactly. Build
project,
stuff.
yeah,
Build stuff.
build stuff. It doesn't matter if you're a developer, sure, try to train a model, learn PyTorch and try something. But if you're not a developer, like play with the model, try it out, use it to build something that isn't necessarily code, or use it to solve a problem for you. I have a post I call the AI step count, right? Just like we have, in step counts, we're
Yeah.
in health and fitness, where we're like, get 10,000 steps in to be healthy. I feel like AI is another thing where you have to use it to get a feeling for how it is. Because AI has this jagged
Yeah.
frontier, as they call it. It's good at some things, it's bad at others. And the only way you're really going to get a feel for it is actually by playing with it. And so give yourself a target. I'm going to use it X number of times a day.
For
So
for
Moderna
example,
CEO, had said he expects all his employees to use it 20 times a day. Just to put it in context, I think it's a bit excessive, but I know I find myself like I'll be in the middle of a project and I realize, oh, I could have used AI to do this
yeah.
faster.
Yeah.
So those are some of the things I'd recommend.
Well, one thing that I've tried, just to add a completion to what you said, is to try to use a model instead of Google. For example, today it was the
Mm,
first time we are planning a trip, and I said I went to Claude and told it find any planes that are flying from Bucharest to Crete in Greece, and make me a table with the departing hours and the price, and it actually got it 80% right, which is exceptionally, because it done that in just, I don't know, a few seconds. For me, it would
yeah,
have taken at least go to Skyscanner, input all the
yeah.
data, compare it, and so on. So yeah, try to use it as much as possible.
Try that's a great forcing function. In fact, for OpenAI Search GPT, it has an option to make it like it's a button there. You can also do it through the browser. You can make it your default search bar experience.
Ah,
The only caveat I would say is make sure you go back and search on Google and double check its work, or Bing or
correct.
whatever. As you mentioned, it's 80%, accurate. You don't know though when that 20% will happen. You'll get a better feel for when that 20% is if you've actually played with it and double checked it a bunch of times. But it's really good, especially in that search context, for things where you're not even sure what the right search query is. You're like, I can explain this to somebody what I'm looking for in a paragraph, but I don't know what I type into Google, or when I type into Google, I get a bunch of unrelevant links.
Correct.
It's really good for things like that. So it's a great example.
Yeah, correct. Correct. And continuing the topic on education, I know that you have an upcoming course on Maven.
Yeah.
Maybe you mentioned it a bit, but maybe you can tell us a few more details about it. What will happen there, and yeah, anything that you find
Yeah,
relevant.
sure. So in the class, it's kind of, as I said, it's a missing AI degree, but really just focused on large language models. So we don't go through anything classical AI, but LLMs are where all the focus is. So we take spreadsheets are all you need, and we walk through tab by tab how every part of it is implemented. So I give the conceptual background. You don't need a lot of calculus or linear algebra. In fact, I show you basically what you need in terms of need to be aware of. You don't even have to, we don't calculate gradients or things like that. I have an example where I do it for you, but like you don't have to know it. And so I give the conceptual background on how things work, and then we walk through its implementation step by step through the sheet. And basically in a matter of 5 hours or so, you can understand how these models work on the inside. It's not, I think outside the realm of accessibility for anybody with, a web development background or anybody with really a STEM background or anybody who can read a spreadsheet. So I think a finance professional or say a patent lawyer as well could go through and understand how these models work inside the class. It's a live class, so I teach it on this platform called Maven.
Yeah.
So me and the rest of the students get on live so I can answer questions as they come up. I also often hold additional hours with students if they have additional questions. And it's basically in 2 formats this month. I have a 2.5-hour sessions, so 2.5-hour sessions, one during the week, and there's another set that happens on weekends. And then I'm also experimenting with a 5 1-hour sessions during Monday through Friday. We'll see which most people like. I actually surveyed past participants and prospective students. We'll see which format works the best.
Okay.
But that's it. It's a crash course on how large language models work. So we go through precisely how the entire thing works. And what I want people to walk out with is 2 things. One is I want them to understand, intuitively and precisely, so no hand wavy explanations. You can literally see how it works. And it's very natural to actually teach this as a spreadsheet. It's not a quirk of engineering that I got GPT-2 to work in a spreadsheet. Large language models are spreadsheets. They're giant calculators more than they're a regular program. Think about, we talk about these models as flops, right? Floating point operations. Yeah. We don't talk, that's how you measure a calculator, right? That's addition, subtraction, division. Those are floating point operations. Nobody talks about Microsoft Office or PowerPoint in terms of flops. So these things are very naturally taught inside a spreadsheet. The other power of having a spreadsheet, as opposed to say, doing it in pure code, is it makes it accessible to anybody. And you can have an explanation, you can watch a video on how these things work, but it's kind of like, the analogy I like to give is debugging your code. You might look at a piece of code and think you know how it works, but how many times have you stepped through and you're like, oh, this is how it really works, right? So by doing a spreadsheet, we give anybody, a non-developer even, the ability to debug their thinking and see precisely how it works. Experiment, what if I change this? And then you make it interactive, because the only way you really understand something is by playing with it. And so that's why the spreadsheet is the heart of the course and makes it so powerful. The last thing I'll just say is, I want somebody who walks out of this course not to feel like, oh, wow, this was an amazing feat of engineering that GPT-2 was implemented in spreadsheet. I want people to think, oh, wow, this was really trivial. This was really simple. Anyone should have been able to do this. Somebody should have done it before this. So that's the class.
Fantastic, fantastic. By the way, I browsed today the Maven's page, the page for the course on Maven, and they also have like what I liked. They have a direct link how to expense this in your training budget. So they make including your email, including the mail you can send to your boss. So I found that addition quite nice, quite
yeah,
fun.
No, absolutely. It's a really good point. For a lot of folks, a lot of companies have, training and professional development budgets. So you can often reimburse some or part of the class.
Good. And now I will play a bit the role of the devil's advocate, and I will play the grumpy old programmer and say, okay, Ishan, this is cool and so on, but why do I need to know as a software developer what is in this black box of an LLM? Why I can only call the API, get the response, and that's it. Why do I have to invest all the time? And what's my benefit investing all the time in understanding what is inside of that black box?
Yeah, it's a great question. So there's a couple reasons. I break into 3 areas. The first is we are in a very fast moving field. And if you want to keep abreast of what's possible and keep current, you need to understand how it works. You can understand, the gist of the latest research. The second one is, especially if you're an engineer or a technical stakeholder, when you communicate with non-technical stakeholders, they're going to treat it as magic. And I have this phrase, magic equals misunderstanding. And so very often they will anthropomorphize it, and you can have a lot of misconceptions about what the model might possibly do, and you're like, whoa, no, that's not going to happen. This is how it works. And then the last one is knowing your tools. It's really important and relevant. Now, you don't have to, be able to build it from scratch, but there is a value. So let me make an analogy. Inside, a classic computer science class, you take this class called computer organization or computer architecture. What they do is they start with a circuit, and then they build a NAND gate, and then they build an ALU, and then eventually you build a whole CPU. And even if you're not going to be, a chip designer, it's still valuable as a developer to understand all the various layers of abstraction. The same thing happens with using a large language model. So I can give a couple examples. So one of the examples I talked about in that talk is there's another type of model called an RWKV architecture. And the prompt template and the order of how you set up the prompts is different from a regular transformer because the attention mechanism is different. Another example is just understanding that these things are purely next token predictors. They're not like thinking the entire way through, leads to understanding how to properly prompt the model. It's very dependent on what it's given in the prompt. There's, Andrew Main, who worked at OpenAI, maybe one of the first prompt engineers. He has a great analogy. He's like, what people don't realize is this thing is like the guy from the movie Memento. I don't know if you've seen the movie Memento.
Yeah, it's a fantastic movie.
He doesn't have any memory, right? So he keeps writing things down. He's like, the model wakes up. It looks at the prompt for the very first time. It doesn't know what it thought about before. And it's like, what is the right thing to complete this sentence? And so you can actually do things like, and this is in the, say, for example, Claude's prompting guide, you can pre-fill the output. So if you want to try and encourage it in one direction, you can pre-fill what its output could be. So maybe, I think they use the example of, what is your favorite color? And you want it to give the answer green and reasons for green. So you pre-fill it as you can put words literally in its mouth. And you have that ability because of the way the model works. Another one is, if you want to ask it to, answer a question, there's this technique called chain of thought prompting, where you say, let's go step by step. So why does that work? Well, it works because once you understand the model is really a giant calculator, and in theory, it has a fixed amount of computation per token. It goes only once through, like a spreadsheet, although in real production, they're doing something different. But in practice, it's only based on a fixed amount of computation. So what you're doing when you do chain of thought is you're giving it more time to compute. You're giving it more compute resources in order to calculate what the right answer is. In fact, there's been research projects that just didn't have real tokens other than they called them thinking tokens, and they improved the results and output of the large language model by that. And so one practical implication of this is, suppose you're prompting the model, you don't just ask it the question, and maybe don't even ask it to think step by step. So say you're doing something like a marketing campaign, you might ask, well, what are the unique value propositions my target persona might want to buy X? And it will list those out. And then you say, now give me the tagline for a marketing campaign around that. And that way you've put essentially into the residual stream the knowledge that the transformer attention will look at and leverage. If you hadn't done that and you just said, give me the tagline for an ad campaign about X, it wouldn't have given you as good a result. So those are some examples where knowing how the model works can actually help inform how you interpret and manipulate it.
Nice. Fantastic. Absolutely. Absolutely brilliant. Um, My next question is about AI agents, and feel free to defer this question. But I'm curious, also mostly from a personal point of view, because I don't have too many people to speak about this topic with. Uh, how would you define AI agents to someone who is new in this field? And also, what is your opinion on them? Because many people are telling that this will be the next big thing in AI. And indeed, they are quite close to how we imagine AI be, like doing decisions, choosing stuff, and so on. So what's your take on this one? And again, this is pure speculation. Nobody can foresee the future, but just out of
Yeah.
curiosity.
So I'll just caveat by saying I don't feel like I'm an authoritative
Exactly.
expert on agents because I haven't delved as much in that. Although actually, it's personally very fascinating to me.
Mhm.
Because I, in my previous web development background, did a lot around browser automation through, Selenium or
Mhm,
like
mhm.
user scripts. I'm a huge
Yeah.
bookmarking fan. I once wrote a application for the iPhone when it first came out called Grease Pocket.
Mhm.
That was basically Grease Monkey, if folks remember that, but for the iPhone browser. Um, so I'm very very interested in this. I actually started a extension for Safari that was to blend the browser and AI together. That was called Start Page AI.
Mhm.
But I got very fascinated by the models themselves, and I plan to get back to that, but I
Yeah.
haven't yet. Um, let's define what an agent is
Please.
first for the audience. So unlike a chatbot, which just has a conversation with you, an agent will go and take action on your behalf. So you talked about, you asked for, plane flights or travel recommendations. So an agent would then go and say, oh, do you want me to book it for you? In fact, you would ask it differently, like book me a flight to X. And the agent might come back and say, oh, here are some options. Or it might even just look at your schedule and book the ticket for you in theory in some far off land. So that's an agent. It operates autonomously. Some of them operate in a loop, so they keep going. There's a lot of potential here where agents can automate a lot of busy work and make things a lot simpler, especially on mobile devices. I don't know. Most people probably had this experience where like, oh, I'll do this when I get to the desktop. But if there was somebody on the phone I could talk to, like if I had
Yeah.
a
Exactly.
virtual assistant, right, and say, hey, could you just do this, and know that they would call you back, and if there was some problem, you'd be like, oh, okay, well, do this instead. That's basically the goal of what we want these AI
Yeah.
agents to be, or virtual assistants. They haven't quite achieved there. We seem to be temptingly close. The famous failure modes for these is they can get trapped. Solving a particular problem, like
Yep.
the coding agents, for example, might get trapped on resolving one particular bug. So it's still a very nascent area, but the ROI, the total addressable market, the potential, both in terms of making our lives easier, but also financially, is so huge. The market has to invest in trying to see if we can make this work. And I'm not going to make a prediction of how long it's going to take, but it feels like we're temptingly close. Now,
Yeah.
self-driving car is an example of a physical agent, right, navigating through the world.
Exactly. Exactly.
And it's that classic example where the future, we overestimate how long something is going to take to arrive, and then completely underestimate when it actually arrives.
Yeah.
Once we get tired of waiting for it, it actually happens sooner. And
Yeah.
that seems to be happening with self-driving cars. Like we thought it
Yeah.
was like
Exactly.
a few years, and now it seems like we're going to happen. But like that
Yeah.
last 20% is going
It
to
took.
be a
It
lot
took a.
more work. Now, I think what we're going to see is not every domain is like self-driving cars. There's a huge amount of regulation. There's a huge amount of safety issues. If it's like something more, let's call it trivial or less dire consequences, we might be able to see agents, really proving themselves in those domains. So that's where I would look first.
Fantastic. By the way, I've recently listened to a podcast with Harrison, the founder of one of the co-founder of LangChain, and he was
Hmm.
telling that they actually had very successful implementations of agents in two fields. One of them is customer support. So, for example, you go on a website, on a web application, and you just type in, okay, how can I fill in this expense report and so on, and the agent will literally walk you through the UI. Click here, do this, and you're done. And the second domain where they got really good results were in working with huge amount of data logs. So enriching the information from those logs, finding trends and so on. That was super easy to do via agents. So yeah, indeed, there aren't there are there aren't as magical as they seem, but still there are some domains where they do right now they are doing a great job. So yeah.
Yeah, I'll say a couple things on that. The second one you mentioned, which is taking unstructured data and making
Mhm.
it structured, I'm extremely bullish on. I think that
Correct.
I don't even consider that. It's so proven to me that It's
Correct.
beyond agents where like
Correct.
if you're not using it for that, you should just already rush as fast as you
Yeah.
can. And I would also recommend this open source tool called BAML,
Mhm.
BAML, which is
Okay.
really helpful in the ability to take unstructured data, use it, put an LLM, and it's another layer on top of it to improve the performance in converting unstructured to structured data. It's a huge unlock from that LLMs are going to enable enterprises. Think about how much unstructured data is out there. Customer support is really interesting. There's a famous counterexample. Like, for self-driving cars, I'll make an analogy. Like we had the DARPA Grand Challenge, right? I think it was like 20 years ago, roughly. And it somebody won that. But to actually have something that works on the road with all the vagaries of real life is something else. So the classic, now canonical example is, I think it was Air Canada. Their agent bot promised a certain rate for a certain situation, and it wasn't their policy, and the customer ended, they weren't going to honor it, and the customer took them to court, and the court said, well, you got to honor what the chatbot said. It's an agent of your company.
Exactly.
So I think you've got to make sure you put the right guardrails on them, and people are going to want to monitor how they do. That being said, there's a really good survey from Bain. It's, I think, called 4 Emerging Themes Around AI. And what they do is they compare across, I think, a 6-month time period. Did executives get more positive or less, more negative about applying AI to these problems based on trying it? And customer support was one of the ones where they continue to get better. The ones that were growing were using it for marketing, using it for customer support. Another one was using it for, code assistance and, code generation. Those are all ones that were improving. There's plenty of other use cases they document where we just haven't figured out either the engineering or the right model or the right prompting to make it work. So those caveats are worth bearing in mind. But yeah, I definitely, for that unstructured to structured, it's
It's
definitely a win. But that's another resource that maybe we should link to. I think it's a great, from a product
mhm,
management
mhm, mhm.
perspective, looking at where at least AI agents are bearing fruit.
Super. Fantastic. Great stuff. Um, And the final question. This is a question that I hope it will become a default question, ending question for the any podcast for this podcast. Is how do you think? What is a good strategy for a programmer? Doesn't matter if it's AI developers, web developer, doesn't matter, to become really valuable for his team, to master his craft. If you have to give advice to, I don't know, someone who just finished university 2 years ago, and they hope to become really valuable, they hope to become a master of this craft. What would you tell them?
Yeah, so I think there's actually 2 questions in there.
Hmm.
How to be valuable to your team and how to master your craft. They're not necessarily the same thing. So on being valuable to your team, I'm going to use the answer, DHH, the creative Ruby on
Yeah,
Rails, has a saying. It's the 10x programmer is the one who redefines the problem. That's the 10x. It's not the one who codes more lines of code than anybody else. It's somebody who sees through the engineering to the end problem you're trying to solve and says, oh, wait, here's a better way to do it. Or here's the real thing we should be doing. It's almost that the engineering should really be a product manager. In fact, I don't think the product manager is the guy who comes up with all the ideas. They're just
okay.
the one who tries to balance everything out, right? And it's why you bring engineers along with you to customer visits, because that's how you get the real insights. So I would say anything that helps you expand beyond just the engineering, actually, and getting closer to the customer is going to help you deliver
Become
more value to your team than probably actually getting better at your engineering craft. Because that's where the rubber meets the road, right? Unless you're a
fantastic.
researcher trying to come out with like the most pioneering research, right? The theory may not matter as much as the practice. Like, it's one of the biggest lessons I've had in my career. And I say this as somebody who went into college planning to be a professor, right? A very academic, and became an entrepreneur. The getting good at your craft, I would say, it's an extension of what we talked about earlier about having a project. Put yourself in a context where you're going to be stretching or learning a ton, but not too much, right? This is like, there's
Yeah.
a field of research called deliberate learning, or deliberate
Mhm.
practice, I should say, right? So that could be going to a startup where you're going to learn, and be immersed and have to wear a ton of different hats. Or it could be going to a large company because they're the only people doing this kind of research. So AI is a great example of it. There are only so many people who have the amount of data and the amount of compute. There's a story
Yeah.
that the CEO of Perplexity said, where I think it was Perplexity, he said he got turned down for a job offer that he extended to a candidate. And the guy said, I'm going to Meta because they got 10,000 GPUs. Do you have 10,000 GPUs? Right. And I can't tell you which was the right job offer to take. But the point there is like, go where you think you're going to expand your knowledge
Yeah.
more so than just going purely for money. Because that's how you're going to get better at your craft, is putting yourself in those contexts.
Super.
And even if
Fantastic.
you're not in any of those situations, it could be just having a project
Yeah.
and just continually learning.
Super. Fantastic stuff. By the way, I think there is a movie made by Guy Ritchie, Revolver is called, and one of the lines in there is something like, "You can only get better by playing with better opponents." So
Oh, yeah, that's a great line. Yes.
yeah, and the movie
Love
is
it.
super good also. So
Oh, I'll have
Revolver,
to
Guy
watch
Ritchie.
that.
Yeah,
Yeah, there's a there's a similar saying I once heard from an entrepreneur, and he said the reward for success is just bigger and bigger competition, and the consequence is having
exactly,
more zeros behind them. But yes, very very similar. I like that
exactly,
line. I might start borrowing that one as well.
exactly. Uh, Super. Ishan, thank you. It was a pleasure. Before we finish this interview, where can people find you and keep in touch with your activity? I will link your
Yeah,
Twitter, but is there any other place you would like to mention?
there's a couple of places. So on Twitter, it's IANAND is my handle, my first initial and then my last name.
Mhm.
You can also find me on LinkedIn, where I also post frequently as well about AI. And then the website for the course, as well as to go download the sheet, even if you're not taking the course, is spreadsheets-are-all-you-need.ai. That's with a hyphen between the words or without a hyphen between the words. I have both versions. And they'll redirect. And there you can go learn more. And there's a link to the course on Maven from there as well. And those are the ways you can get a hold of me.
Super, super. Thank you very much and
Thank
wish you
you
all
for
the
having me.
best. Cheers.